Okay, so now we're going to use some of those radical rules from the last video to simplify radicals like these examples here. But first, just to warm up to that, let's remind yourself of some rules for radicals here that you're going to be using, and this will get you a little practice to help understand these videos that to do these examples we're about to do. So, anyways, let's give this a shot. Here's what I got. So the first one, I raised the two factors here, 2 and x, each to the power 5. That works when you have multiplication between them, but remember not if it's addition. So anyways, 2 to the 5 is 32. And then we've got an x to the 5 times x squared. That becomes x to the power 2 plus 5, also known as x to the 7th power. And that combined with the 3 times 32 is 96 times x to the 7th. Over here, we're going to do the x to the power 4 and also the y to the power 4. Notice here that the 8 that you got comes from doing 2 times 4, not 2 plus 4. And then when you combine all the exponents, you got x times x to the 4th is x to the 5th, and y to the power 3 times y to the power 8 becomes y to the power 3 plus 8. And over here, the fourth root and raising something to the 4th power cancels out. So yeah, I just want to notice that you could write this also, if you wanted to write it, as the 4th root of x to the 4th y to the 8. And I want to point that out because problems like this are what we're going to be faced with a lot of the time in this section, is how to simplify a radical like this. And generally, the goal is going to be to take that stuff inside the radical and write it as something to the 4th power and try to get that 4th power matched up with the 4th root, because then they cancel out. So anyways, here's an example, and of course you should maybe try these examples on your own. If you're feeling confident, you don't have to, because I'm going to show it to you here, but you'll get more out of it the more that you do on your own. So anyways, here is how I would do this one, is say, I know that if you take a cube root of whatever you got but that's written as the 3rd power, the cube root and the 3rd power cancel out, and you just get whatever you got. So that's what I'm going to try to do, is write part of this as something cubed. And the trick is that x to the power 11, I could write it as x to the power 9 times x to the power 2. And I'm picking 9 and 2, well, partially because they add up to 11, which they need to do, but also because x to the 9 you can write as something cubed. You can write it as x to the power 3, also to the power 3, because then those multiply to make 9. So that means that when we're taking the cube root of all of this, the cube root of x to the 11, it is going to cancel out if I do it separately with the x to the 9th part here. That times the cube root of x squared, which you can't simplify. So the cube root of x to the 9th power is the same thing as x to the power 3 cubed, and so the cube root cancels out with the exponent 3 there, and you just get x to the power 3 times the cube root of x squared, which you can't do anything with. So that's as far as that gets simplified. So kind of the way I came up with the x to the 9th and why I chose that is that I wanted a multiple of 3. I wanted some number that I could multiply by 3 to get that, because, or you can think of it another way, this number 9 is something that you can divide by 3 and have it come out evenly so that you get x to the power 3 left over. Anyways, that's how that goes. let's give it a shot on this next one. This one you definitely have to do yourself. And let's try it. And I'll show you the answer in a minute. Here's what I got. So the idea is it's a fourth root here, and that means that we need to have a perfect fourth power, which means some part of a to the power 15, which we can write as the power 4. So I tried to find a multiple of 4 that would add up to 15. So that's where I got that 12 from. 12 is the biggest multiple of 4 that's less than 15. So, and when you come up with that, then you can see that a to the 12 is also known as a to the power 3 to the power 4. So just rewriting the a to the 15th this way lets you take that fourth root, and that becomes a to the power 3 here, because the fourth root and the fourth power cancel out. And over here, the fourth root and the third power don't cancel out. You can't do anything with that. But anyways, that's what you get. Good job if you got that. This is a tricky concept. Now let's look at another example. Okay, here's a kind of more complicated example here. So what we're going to do is take the square root of 18x to the 5th and take the stuff inside the square root, that 18 times x to the 5th, and we're going to try to factor it like we did before. Write it as some stuff times some other stuff so we can split up the square root and take the square roots of some perfect squares. So first I'm going to start with the 18 here. I want to write 18 in such a way that it is something squared times something else. So, and another, because then when we take the square root of it, we'll be able to take the square root of the something squared part separately. So think of factors of 18, and you could say, oh, 18 is 6 times 3, but 6 is not a perfect square, so that doesn't work. And then you say, oh, 18 is 9 times 2. Oh, that will work. That 9 you can write as 3 squared, and then that times 2. And that's how you can do that, and that way you'll have a perfect square that will cancel out with the square root here. So let's do the same thing with the x to the 5th. I want to write that as something squared times something else to get x to the 5th here. So let's see. X to the 4th times x might work, because x to the 4th is also known as x to the power 2 to the power 2, because 2 times 2 is 4. So this gives you 2 to the power 4 times x to the power 4 times x, which is the same thing as x to the 5. So I worked that out so that we'd be able to write this as things that are squared, that are factors of 18x to the 5. And you might have another way of doing this that works. You don't have to write it all out the same way, but just trying to make it explicit so you can have a way of thinking about it if you get stuck. So we got the square root of 3 squared times 2 times x squared, that's the x to the 4th part, times x. There's this intermediate step that you don't really have to write every time, but it doesn't hurt. We got the square root of the 3 squared times the square root of the 2 times the square root of x squared times the square root of x. And I say it's intermediate because you might be able to skip this step here. Because the important thing is that you turn the square root of the 3 squared into 3, the square root of the x squared into just x squared, and then the square root of 2x is left over on the inside. And you could just go to this last step here if you want. Okay, then with part B here, this is A. So with B, we're going to try to do the same thing. I'll think of the 24 and the x to the 6th and the y to the 8th slightly separately this time. So we got 24, x to the 6th, y to the 8th. We want to, because this is now a cube root, we want to write this as something cubed times something else. That makes that 24. And then we're also going to try to rewrite the x to the 6th part there, and also try to rewrite the y to the, computer trouble. Here we are. Also try to rewrite the y to the 8th there, and with each of these as something cubed as part of it, because we want that to match up with the cube root. So let's see, 24, the trick with 24 is that is 8 times 3, and 8 is a perfect cube, so we can write that as 2 times 2 times 2, so it's 2 cubed times 3. And then the x to the 6th, you could just write that x to the 6th as x to the power 2 cubed. And then the y to the 8th, well, 8 isn't just 3 times something, so we could say there's a y to the 6th, and y to the 6th is the same thing as y to the power 2 to the power 3. So that's how that will factor out. So then when you take the cube root of all that stuff, here's how it will break down. This time I'm kind of skipping this intermediate step because it would just be annoying. But you can see the cube root here will be able to cancel out with all of these third powers, and those things are what just ended up on the outside over here. And the stuff that you could not take a perfect cube root of ends up still inside the radical. And that's how that works out. It is pretty tricky. Here is one for you to do. This is definitely a tough kind of problem, but let's give it a shot. And it's okay if you get it wrong. Just try it. You can see what your mistakes are after I show the correct stuff here. Here's the perfect cube factors of 250b to the 7th that I got. Then using the product rule here to say I'm going to do these separately, take the cube root of 125 and the cube root of b to the 6th separately to get that 5b squared, and then leaving the 2b, which you can't take a cube root of on the inside. So yeah, the answer here is the cube root of 2b is part of it, or if you got it wrong, it is not 2b.